It is a gentle request to everyone present to maintain silence and preserve the decorum of the occasion by ensuring that mobile devices are kept on silent mode. Thank you. Good morning, respected dignitaries, Dr. Hitesh Srimali, Professor Dinesh Avasthi, respected panel members, advisory council members, steering council members, organizing committee members, and session chairs, esteemed directors from respective departments and heads of departments, dear professors, researchers, and students. I am Dr. Anuradha Acharya, Associate Professor at the Department of Master of Science in Information Technology, MSCIT. It is an absolute privilege and honor to warmly welcome each of you present in the auditorium on this significant gathering of the third International Conference on Modern Optimization and Technological Advancement for Resilient Smart Systems, ICMO-TARSS 2026. The conference has been proudly organized by LJ Institute of Computer Applications, LJICA, Lok Jagruti Kendra University, LJKU, in hybrid mode in association with the Institute for Educational Research and Publication, IFERP. It is a matter of great pride to have such a gathering of brilliant minds under one roof today, ready to share knowledge and explore new horizons in technology and research. The presence of our esteemed guests adds immense value and dignity to this event. As a symbol of our gratitude and appreciation, I would like to welcome Dr. Hitesh Srimali, Professor Dinesh Avasthi, and Dr. Alok Mankion. May I now invite Dr. Alok Mankion, the convener of this conference and director, LJICA, to present the welcome address.
Okay. Both are technical problem. Very good morning to one and all. It's my proud privilege and honor to stand before you today, deliver the welcome address for the third International Conference on Modern Optimization and Technological Advancement in Resilient Smart System. I request Dr. Avasthi to welcome Dr. Srimali with Tulsi pot. To mark this auspicious occasion, beginning and welcome our guest with warm tradition, to also present the Tulsi pot. I invite Sir and Shimali Sir for lamp lightning so we can initiate our event. Please. I would like to extend heartful and warm welcome to our Vice Chancellor Sir Dr. Dinesh Avasthi, Dr. Hitesh Rimali from prestigious Indian Institute of Technology, Mandi. Sir, we are thrilled to have with you us. Eagerly look forward to insights. Thank you very much, sir. We are also honored to welcome all the directors from different institute of LJ University. And I also wish to extend my warm welcome to deans, HODs of all the department, faculty members, and session chairs. My special welcome to Mr. Suprit Tare, Mr. Rumit Gandhi, Mr. Rajneesh Tripathi, Mr. Divyang Ved, and they are panelists. So we are also having the panel discussion after Vice Chancellor's speech. And I also extend my warm welcome to distinguished session chair and students. So I am proudly announce that we have received more than 500 abstracts from 6 different countries, and after rigorous review we have accepted 145 high quality papers for presentation. This is truly reflect the global relevance and theme and commitment to the research community to build resilient smart system. Thank you very much.
Thank you, sir. The recitation of Saraswati Vandana seeks the blessings of Goddess knowledge and wisdom, paving the way for success and harmony. I cordially invite Professor Bhavi Bhatt to present the Vandana.
Sharde, Sharde, Sharde. Sharde, Jaya Hans Vahini, Jayati Veena Vadini. Sharde, Jaya Hans Vahini, Jayati Veena Vadini. Jaya Saraswati ज्ञान गायिनी, जय सरस्वती ज्ञान दायिनी, कमल हंस विलासिनी. शारदे जय हंस वाहिनी, जयति वीणा वादिनी. जय हंसवाहिनी जयति वीणावादिनी शारदे जय हंसवाहिनी जयति वीणावादिनी.
Thank you, Professor Bhatt. This moment becomes even more significant as we proudly present the official journal, the Journal of Statistics and Management Systems, JSMS, indexed in ABDC, Volume 28, November 2025, a special issue on emerging trends in technological development and management practices. This special issue guest edited by Dr. Nehasha and Dr. Pooja Gandhi with support of scientific committee members Dr. Jignesh Doshi, Dr. Bhavin Shah, Dr. Monica Gahlawat, Dr. Mitu Joshi, Dr. Urja Mankad, Dr. Anuradha Acharya, Dr. Sheetal Soni, Dr. Prashant Petalia, Dr. Mehul Patel, Dr. Vishant Polara, Dr. Hardik Soni, Dr. Khyati Rami, Dr. Kalyani Patel, Dr. Meghna Patel, Dr. Priyanka Nahar, and Dr. R.P. Jani, under the guidance of Honorable Director, LJICA, Dr. Alok Manke, Honorable President, LJKU, Dr. Manisha, Honorable Vice Chancellor, LJKU, Professor Dinesh Avasthi, features the blind peer-reviewed research papers presented at last year's conference, the second international conference on recent advances in engineering and computer applications, ICRA ECA 2025. The contributions from the associated editorial members. May I respectfully request our eminent personalities to kindly unveil it. Many congratulations to the organizing committee and all the contributing authors and editors. With this, I invite my co-host, Dr. Urja Mankad, HOD Department of MCA, to the podium to conduct the upcoming keynote and presidential addresses.
Thank you, Dr. Acharya. Good morning, all. We are thrilled to move forward to the highly anticipated keynote address. We are having gratifying moment of hearing from Dr. Hitesh Shrimali, who is the keynote speaker of today's event. Before inviting him to deliver his address, allow me to briefly introduce him. Dr. Hitesh Shrimali is full professor in the School of Computing and Electrical Engineering at IIT Mandi and a member of its Board of Governors. He earned his BE from Nirma Institute of Technology, MTech from IIT Kharagpur, and PhD from IIT Delhi. Before joining IIT Mandi, he worked as a senior design engineer at ST Microelectronics, Greater Noida, and completed postdoctoral research at the University of Milan in collaboration with INFN Milano. He has held several key roles at IIT Mandi, including Dean Students, Program Controller, VLSI, and coordinator of the IP and Technology Transfer Cell. His research specializes in radiation hard circuit design, analog and mixed signal VLSI systems, modeling radiation effects, and on-chip instrumentation. Under his guidance, multiple chips have been successfully tapped out for applications such as dosimetry, thermoelectric cooler controllers, high voltage front-end electronics, EEG front-end circuits, and hybrid flash SAR ADCs. He is a recipient of the Young Faculty Research Fellowship, METI, and has received awards from IIT Mandi for excellence in teaching and institutional service. Let us warmly welcome him to the podium. Please welcome, sir.
There are certain glitches, so they'll fix it and then we'll start. So, as already introduced by professor, that yeah, I'm with the School of Computing and Electrical Engineering. By the way, I'm audible, right? At the back, at the back. Okay. So, I'm basically in chip design. I do chip design. Note that when I used to study long back, like almost 26 years back, when I was in my BTech. At that time, I used to study neural network. It does not have the name called machine learning. However, even it was not intelligence enough also, because we didn't have good number of data and it was not mature enough. However, we studied that. Most of the professors, maybe before this century, people were studying neural network, and even IoT and those things were present, but we didn't know how to use them, how to make it intelligent enough, because the missing thing was the data. Most of the data was also like digital we were expecting. It was not analog. And that is how this name, like my major area is analog and mixed signal VLSI design. Even though I treat all the signals analog, but I give that signal in a digital world. So it requires some sort of block known as analog to digital converter. Sometimes it's not only analog to digital, but at the same time, if you want to get it back, it requires digital to analog converter also. Other than that, there are not only about analog to digital converter. Sometimes we want to convert time also to digital, and same way digital to time, right? So all these data converters are my specialties, that how to convert them and give it to the world, digital world. if you do not have good digital data, then you can't have the, you can't process it, right? So what do you think? What is the highest number? Do you understand the number of bits? Do we understand, right? All students, I'm addressing you students only, right? Considering like all professor, other people know that. So what do you think? Digital is actually restricted with the number of bits, right? So how many number of bits do you think it's possible? How many number of bits are possible? Maximum. Somebody can answer it. Till the time we don't have the presentation, we can ask this question to any. It's done. Okay, then we should go next. Okay, go next. Still, it's not started yet. Mine is not. So generally, like the number of bits, it depends. If you are in very high speed, believe me, you can't have more than something like 7-8 bits. If you can achieve 6 bits, then also fine. But more than 7-8 bits at so much of high frequency in gigahertz, right? So let's say you are in 5G. What is the transmission speed in that? 5G has around 5 gigahertz or around in that range. So for that, you can go at the max something like 6 to 7 bits. But if you want to go for higher, you can go for something called time interleave technique. So those techniques are there to achieve the high number of bits, but you can't go more than something like 12-13 bits at very high speed. So you need to think about some algorithm, you need to think about some optimization which is going to give you the high number of bits, because that is what you are expecting. You want to run, let's say gaming application where it works very fast. It's not working at 140 fps, sometimes even much higher than that. So for such kind of things you require some kind of good data converters, right? And one more thing I can tell you, in my introduction even told that it's my specialty, that radiation hard. So what is radiation hard is, if you are designing something on harsh environment, like for SAC ISRO is here. So for different mission on moon, on Mars, if you are sending your chip, it is exposed to high amount of heavy particles, high energy physics is involved. So under those radiation also this circuit should work. If you know that like if you are talking about, let's say, Ohm's law, if I'm asking to everyone, we will say that V equal to IR, but that's not the complete thing. V equal to IR at room temperature. Do you agree? It's only at room temperature. But what's going to happen if you are not at 27 degree? It's going to change, right? Even all the consumer electronics on earth, whichever we are using, it has to be designed from -40 to 125 degree. It's not only at 27 degree where the Ohm's law has been characterized. It has to be from -40 to 125 degree where all the non-linear things are happening, right? So non-linear polynomials will be there, and you have to take care of those things, and your electronics should work with that. Are we ready? Just wait a minute. So yeah, so I was talking about data converters. So few techniques I'm going to talk about. That presentation I sent it to Samarth, right? So he will make it on and I'll talk about it. And in that presentation, I'm also going to talk about Mandi, that where we are Mandi is in the state of Himachal Pradesh, by the way. And I'm also telling, as I was dean student at IIT Mandi for almost for 3 years, I used to tell my students that you are at the topmost IIT because it is the only IIT which is available at 1,300 meter, which is actually very high. And at the same time, we are also very rank wise also very prestigious in terms of entrepreneurs. I'm also board of director for Catalyst. So in that, we are also inviting lots of startups. We have highest number of startups in past few years. For that also, we are getting the first rank, and we got the award from the ministry. So IIT Mandi is doing excellent job in many things, which is living in the Himachal Valley. We are having the best laboratory for fabrication of the chip. That's available in our uh, Himachal Valley, right? So that's also there. Other than that, we also have many good courses are running, like BTech in VLSI. So VLSI stands for Very Large Scale Integration, and that's chip designing. We're teaching them all the fabrication, design, all other things, including, this includes AI ML also. Look, we consider AI ML is a tool for all the branches. It's not only about one branch which is going to deal with AI and ML. However, you have to understand it, you have to look at other branches like mechanical, civil, because they are not known to us. Those who are not into that field, mechanical, civil, or electrical or other field, where they are not known to AI ML, then they will not get upgraded. However, if you look at the real world, it's not only computer science, it's not only digital going in air. You require good hardware, you require, the mechanical structure, you require, the infrastructure, the civil engineering. So all these things are required, which has to be integrated with AI ML. So in our course curriculum, we are also having everywhere like AI ML is a part of it, which is the fundamental thing at the beginning. We call it the institute core courses, where we have Python, all these things, AI ML, data science, including like we also have MBA, which is in data science and machine learning. So it has to be integrated everywhere. It's not about the one field. So what you are doing right now, or what about this field, it's not only about just one discipline, which is AI and ML, but it's actually a kind of potato. In every dish you will have it. So you can't go without AI and ML. So that is the most important part. And when you are going with this AI and ML, you can also have the IoT, Internet of Things, because actually the world is connected through Internet of Things. And the most important part is all these things which are happening, they require digital data. The most important part. That's why in electronics also, the thing is you need to have good data converters, ADC. That is what I work in. And of course, considering the need of India, where we are very aggressively working on space technology, we are working on harsh environment, or the even sometimes for defense. So I generally try to work with those projects which are actually as a part of our ISRO or DRDO, where I can help them on chip electronics. So I try to make smaller and smaller technology. And the good part of all these circuits are, we are not into something like 1 nanometer, right? If you know the Moore's law says that every 1.5 years, the number of transistors which are on chip are going to be reduced by 0.7 times. So this is going to happen like when I used to be in company, like it was 28 nanometer in 2011. So after 1.5 years, it becomes 21 nanometer. Next 1.5 years, it becomes 14 nanometer, then 7, then 1 nanometer. So we are almost at 1 nanometer. So the good part of radiation hard or the space technology, it does not require very small electronics. And that is how like even SCL, which is Semiconductor Laboratory in Mohali, which was part of ISRO, right? Right now it's under MIT. However, earlier it was ISRO, and it was running the whole electronics at 180 nanometer. Now they are trying to uplift them to 28 nanometer, but 180 nanometer is good enough for any space technology. That is the place where like all Indian researchers or academicians, they are actually contributing in terms of designing their circuits, and that is also the place where I am also trying to contribute. Are we ready or ready? Okay. So these are the things, like I'm working on radiation hard circuits, which is ISRO and DRDO's project. I also work on analog and mixed signal VLSI circuits. Means when the input is digital, output is analog, or sometimes both are digitals, both are. So if there is one side is digital and one side is any analog quantity, all are considered as mixed signal, right? And this is limited with the number of bits. So how many number of bits do you want, right? If you want something like 20-25 bits, it's not the real thing, and it's not possible also. You need to go for something called, different algorithms, different techniques, which are very much useful. By the way, have you heard about binary search algorithm? Have you heard about binary search algorithm? Anyone? What is that? What it does? Binary search algorithm. So that is also important in analog to digital converter, which is also known as the successive approximation register, where that was written here, hybrid flash SAR ADC, right? So SAR ADC using a binary search algorithm, and at the front side we are using flash, which is the fastest one. How you can combine both of them to get the digital output, which is very high speed. My target is to achieve very high speed and at the same time energy efficient. And it's freeze. Okay. Can you give it to me? I'll just no. Okay. Okay. Can you go to next? Okay, go back. So this is almost like 10 years back. I took the photograph from the different side of hill, which is known as the Kaman Valley. Kaman Valley is around 30 minutes from Mandi city. Other side you can see some snow covered mountains. Those are the Kullu Valley. Kullu Valley is just 1 hour from Mandi district, and from IIT Mandi. The whole mountain is part of IIT Mandi, this side. Can you have some your pointer or something? Okay. So you can see both sides. One side is known as the north campus, one side is known as the south campus. As I told you, like, it was taken almost 10 years back, so still it was under construction category. However, now it's a full-fledged IIT, which has around 4,500 students. There is a full residential campus where all students, all faculties, all staffs are staying inside, and we have all the facilities. Can you go next? So this is the north campus. It was taken 5 years back, this photograph. So it has fully central heated facility, because this campus goes experiencing almost like -7 degree in winter, and the maximum temperature which goes in IIT Mandi is around maximum 30 degree, maybe in June, July. That's the summer, and during like this time it should be around 1 or 2 degree right now in IIT Mandi. Going next. So this is the south campus, other side of that mountain, and it is on the bank of river Ul, which is merging with Bias in Mandi city. Going next. So as I told you, like every year we also have snow in the campus. Even that first one is my apartment. So it goes as low as -7 degree. We have good facilities. We have good all hostel facilities. Right side we also have the best facility for fabrication. So combining all IITs or even ISC, we have the best facility in terms of fabrication, which is class 100 clean room is available. Going next. So this is our group only in chip designing in School of Computing and Electrical Engineering. So we do not have electronics department separately, because uh, it's actually borderline. Electronics and chip designing is actually in between computing and electrical engineering. So we are part of computing and electrical engineering. Many faculties are there who are also teaching computer science. Some people are teaching, you know, uh, VLSI side, but it's a combination of both. And we have all the facilities, including chip designing, which is analog and mixed signal, RFIC design. We have device fabrication, modeling, characterization, all such things, along with digital VLSI architecture, digital MOS LSI circuits, even spectrum sensing, channel decoders, biomedical systems. And the most important part for all such things are we require good semiconductor materials. So those facilities are also part of our group. One more faculty has joined after just last month. So we have around 13 faculties in chip designing in IIT Mandi. So this is only from School of Computing. However, we have more faculties from thank you. Okay, so we have more faculties from other schools also, like you have different schools. So we also have School of Mechanical and Material Science. We have School of Chemical Science, because believe me, when people are saying about chip designing, if you go to whenever you will have the chip design in Gujarat or maybe rest of the part of country, you will see that it's a chemical factory. So without chemical engineering, chemical things, if you are not aware of that, you can't build the chip designing factory over here. So that's what going on, and it includes all the facilities as a part of the school. Going next. Samar. So in my group, I work on radiation hard circuits. As I told you, like signal and power integrity is also very important when we are saying that ones and zeros are required in your circuit, right? Digital output has to be purely ones and zeros, but there is a fluctuations. Those fluctuations are known as the jitter, which has to be seen on the eye diagram. When you are going to see that, you will experience that there is a jitter. So there are various kind of jitter as there, but we are going I generally work on power supply induced jitter, which is actually violating some of the problems with the digital circuits. I also work on data converters, specifically on space application and sometimes on biomedical imaging applications. And nowadays I work on chip scale atomic clock, which is a DRDO's ongoing project. Going next. So general transceiver architecture, if you look at, you will see that the most important structure over here is ADC and DAC, which is analog to digital converter. And believe me, this is also part of your mobile phone, where there is a transmitter as well as receiver, which is playing the important role. This is also true for many other IoT application, many other 5.0 industry. So everywhere, analog to digital converter and digital to analog converters are playing a crucial role. So we are going to talk about a bit. We'll go next. So when we are going to have any ADC, you have to have the number of bits, sampling rate, and power consumption, right? You do not want a mobile phone which is going to hit up. You want actually good sampling rate, which is matching with your 5G right now. And if it is 6G, 6G does not mean only 6 gigahertz. It has to be from our telecommunication ministry, where they are going to tell us what will be the 6G and all these things from the world standard, and the number of bits. We always want the high number of bits. So those are the critical specification, but we have to have some trade-off, which is known as the figure of merit. So we will discuss about that how the figure of merit, which is having the unit of femtojoule or sometimes picojoule. So it's in energy. So that energy has to be reduced. There are various architectures are available, like flash, SAR, pipeline, and hybrid. Flash is the fastest one. SAR is another one which can give you hardly the number of bits might be something like 8 to 10 bits. Flash can give you 3 to 4 bits. Pipeline give you more number of bits with high speed. If you want to have better number of bits and the speed, you can go with the hybrid. I'm going to take care of flash and SAR together, but let's go next. This is just to give you some glimpse that what are the numbers when we are talking about the numbers, because some people do not know high power consumption, low power consumption, what is the meaning of that, right? So those who are doing maybe engineering and studied somewhere transistor, your teacher might have told you that if you are getting anywhere milliwatt or milliampere of current, means you are in the safe range. If you are getting something else, means your transistor might not work, means I'm talking about BJT. But when you are going into the MOSFET, which is CMOS technology, then the technology wise, if you are in 100 gigasamples per second, if you look at the third number, it is almost like 3.1 milliwatt. 3.1 milliwatt at 8 bit in gigahertz range, that's the normal one, right? So, and if you are increasing the speed, you know that with respect to speed, the energy will be increasing or the power consumption will be increasing. So that's going to happen. Note that all these conference and journals which has been listed, that's the number one in around the world. If you go anywhere, if you want to get the degree from, let's say, Stanford, you have to have the journal paper over here. And ISSCC, it's only happening in San Francisco every year during the February time. So these are the data which is actually very authenticate, right? Going next. So these are again same thing, that how much number of bits you can achieve for a given given power consumption. So you should not go more than something like in milliwatt. Still, it's less than 100 milliwatt will be helpful to have something in 1 giga. Next. This is again taken from ISSCC, so 97 to 2021. If you look at the bandwidth versus figure of merit is nothing but a energy which is in femtojoule per conversion step. So how much time is required to get conversion from analog value to a digital number of bits. So that much number of cycles for a given clock. I believe everybody understands clock, which is available in any digital system, which is sequential logic circuits where you have the clock. So how many clocks are required to give you the digital output? So that is we are talking about. So for the conversion step, that might not be just single, it might be 2, sometimes 12, sometimes more than that, depending on what architecture, what algorithm are you following. So if you look at with respect to bandwidth, the figure of merit, which is in femtojoule per conversion step, is increasing. And for different different conferences where it was published, it shows that it's significantly increasing, and the x-axis is actually in log scale. So it's not linearly increasing, it's exponentially increasing beyond 1 gigahertz, right? Next. Same way, there is something called ENOP. We do not call number of bits, we call it effective number of bits. The effective number of bits which you can achieve with respect to the bandwidth. So if you are going in gigahertz, the number of bits which can be achieved is not more than 5 or 6. So that is also the another important thing you need to know. Going next. So as I told you, like if you are using SAR or the successive approximation register, it is a low power consumption for high resolution. So resolution is number of bits which are going to be denoted as n. It is not so much high speed, it's medium speed. When we are saying medium speed, that is going to be around in megahertz of range, not in gigahertz, but it requires conversion speed of n clock cycles. Note that successive approximation register is using binary search algorithm, and to read that value, it has to run the whole circuit for n times. When it's running n times, it requires n clock cycles. And there is another one which is flash ADC, but which is running in parallel. So it's going to give you, the answer in single clock cycle. It's very fast, but it requires lots of hardware. That's why it consumes higher power. So it is restricted to something like 3 or 4 bits. It cannot go beyond that. Going next. There are many other techniques are there, which is very complicated right now, so we are not going into that. Next. So this is the flash architecture where you have the 2 raised to n number of comparator, and the output which is coming, it's not in binary. Note that there are various codes are there, but they are not considered as always a binary code or the digital code. Those will be in different code. Here it's going to be thermometric code. If you know that thermometric code is going to give you all ones together, and maybe wherever it's transition, all will be 0. So those needs to be converted to binary through something called encoder, and you will have the digital output. Next. But if you look at the SAR architecture, which is using the binary search algorithm, it's hardware efficient. It has only few blocks are there, where most of the blocks are digital, and you can generate it through the coding called VHDL or maybe Verilog, which is very popular in industry, or even whatever you want to design, you can go with those programming languages, and you can have the output. But this requires n times, this whole architecture will run, and it will give the output after n clock cycles. So if you are interested in 10 bits, you can achieve 10 bits after 10 clock cycle. So if your clock cycle is running at 1 gigahertz, let's say, then it's going to give you the output after 100 megahertz, right? So it's not available at every clock cycle, as I told you. This will have some energy efficiency also, which is in joule per conversion step, right? Going next. So what we can do is, you can combine both the structures together, flash and SAR ADC, and so the combining both flash and SAR will give you the answer, and the total number of conversion speed will be n divided by p, where p is the number of bits generated by flash, and n number of bits generated by the successive approximation register. So n by p is the conversion cycle. So if you are interested in, let's say, 9 bits, and if you are designing 3 bits flash with the flash, the output is available after 3 clock cycle, unlike the case of SAR ADC, which was taking n number of clock cycles. So that way it is fast. Going next. So these are some of the, how the binary search algorithm along with the flash has been used. That flowchart has been kept. Next. So here there are various possibilities are there. One can make the comparator optimization. One can make this comparator such a way that it's energy efficient, right? Another is the digital to analog converter, which is inherent part of this structure, that can be designed accordingly. And another one is SAR optimization, and of course one can make the efficient clock optimization, which is not part of this presentation. However, the clock optimization, which is coming through the phase lock loop PLL, can be designed over here. Next. So this structure is actually the real structure, where the number of DACs are 8 DACs kept, and along with that there are 8 comparators and 1 SAR logic, which is actually designed from the digital programming, right? Next. So these are the salient features, that you are going to have the conversion speed by n by m plus 1. Plus 1 is actually for end of conversion, so that has not been kept in ideal mode. However, it's going to take 1 extra clock, right? Next. Yeah. So these were the specifications. I got it from let's say from TU Berlin, because this was the project with Berlin. So they gave me this specification, and I tried with the achieving the figure of merit, which is power by E knob 2 raised to E knob times Fs. Fs is the sampling frequency, E knob is effective number of bits, and FOM is figure of merit measured in joule per conversion step. Next. So these are the specs derived from all these requirement with the budgeted things, and that has been kept over here with the optimization, all the required things. Okay, next. So in case if you understand the inverter, let's say, so if you look at the PMOS, so with the bubble is known as PMOS, and NMOS is just a without bubble. M1 and M2 are denoted with those transistors. If input is logic high, then M2 will be on, and if Vin is equal to 0, then M1 equal to M1 is going to on. Means whenever there is a PMOS will be there, it's going to operate with the digital logic 0. NMOS operated with digital logic 1. Means if I'm going to apply logic 1 at input side, M2 is going to be on, M1 is off, and M2 is connected to ground. Ground is 0 volt. So those, the earthing one, it's actually the ground, which is connected to the output.
Means if you are applying input as 1, output is 0. Same way, if you are applying 0 input, the PMOS is going to become on and output is connected to that antenna, which is VDD, which is logic 1, right? So VDD is equal to logic 1 and ground is equal to logic 0. So it's an inverter. So one inverter is going to give you the output, and note that in reality there is also transition between 1 and 0. So if it is not 1 and 0 purely, in between there is a transition. So generally whenever there is input is equal to VDD by 2, output is also VDD by 2, because it's not either of the side. So plus delta, VDD by 2 plus delta is there, then output is equal to logic 0. VDD by 2 minus delta is going to give you output is equal to logic 1, because input is treating as logic 0 and 1. It's based on purely on noise margin high and noise margin low. Maybe you can skip this. Few more. Next. So what we designed was, it's a inverter based comparator which was designed, which is having the comparison with some common mode voltage. It gives output. This is the important term, unfortunately not given in book, but it has to be learned, known as the PVT. P stands for process, V stands for voltage, and T stands for temperature. As I told you, like all the circuit has to work from -42 plus 125 degree, and all the circuit has to work between plus or minus 10% of supply voltage. So your mobile phone might be working at 3.7 volt battery. However, when it's fully charged, it can go till 4.2 volt. If it is about to get discharged, that can go up to around 1.2 volt. You can check it. When I was doing like almost my BTech, I used to check it, and with that also your circuit should work. So that's the overall theme, and what circuit we have given was working with the PVT. So that has to be understood, and that has to be taken into account for any circuit or anything you are designing on hardware. Next. So these are some of the results. Go next. Going next in that. So here there is a structure which is inside the charge scale deck, which are having many capacitors in parallel. Each one of them is designed such a way that it's a binary weighted. If you look at that, it's 1C, 2C, 4C, 8C, 16C and 32C for achieving almost like 7 bits of DAC, right? If you want more, you can go with the more structure. Just to avoid some of the errors like INL, DNL, we use segmented CDAC, because segmented CDAC is working with thermometric code, whereas the CDAC conventional one is working with the binary coded. Yeah. Next. Going next. So these are some of the results where you can see if there is a FFT or the fast Fourier transform. If you look at that, the output is measured in terms of SNR. Generally, SNR is measured as SNR is equal to 6.02 n plus 1.76. So through that you can find out the actual achieved number of bits. So that gives you around 5 to 6 bits of operation for around gigahertz of sampling rate. Next. Going next. So these are some of the results. We can skip it. Going next. Yeah. So here, if you look at referring back to the original architecture which has been started with, now what we are seeing that the output is actually thermometric code. So why to work with binary coded? You can go with the thermometric, and that is what has been done. Next. So this structure is the one which has been designed with the thermometric code, where they are not working with binary, and thermometric code is going to give you the good result. Next. This has been checked in terms of the switching energy, checked with the half MV square, the energy burned by each DAC, and that gives the answer. Next. So this circuit has been tapped out. When we are saying tapped out, this is a very popular word in chip designing. Tap out means we are sending our chip for the fabrication, and they are going to give us the silicon tap. So that tap is out. That's why we are calling it tap out. So this silicon has been tapped out from IMEC Belgium. So there are very few places where you can get the fabrication. Unfortunately, not happening in India. So this is for 130 nanometer technology, which has been done. That costed me something like, for 1.5 by 1.5 mm square of area, it's costing something like 15 lakhs. And they are going to give us only 10 chips. I'm telling you because you know that why the requirement of chip fabrication is there in India, and that's why like we may get the help from government of India when we have these chips here fabrication. Then we are not supposed to go to IMEC Belgium or the Silicon Valley, right? Where they are going to have their own tariffs. We do not have our discounted prices also because we are not European Union, right? So that way, this is very important. Okay, next. So those results has been checked in IIT Mandi as well as IIT Delhi. Going next. So we are skipping the result. And if you look at the work wise, the figure of merit, which was in femtojoule per conversion step, it was giving me something like 195 femtojoule. So it is quite better. Going next. So as I told you, like there is another technique, that power aware ADC. By the way, all these structures has been patented, and they are granted also now because this is an old PPT. So this was again like patented, where what we are doing is each output, which is Q0 to Q6, are thermometric, and as we know that digital output in thermometric, there is only transition place where we are going to see 1 and 0. Other places are 0, or maybe other side only 1. So we are going to make the off only at the transition. So where it's logic 1 and where other side it's 0, we are going to have the output, and that going to give me the output at every clock cycle. Next. So this power aware ADC, where it has been optimized for the required digital logic 1 and 0. So as I told you, if you look at this digital code, thermometric code, which is having all 1 together and 0 together. So it will not be it's never going to be like 0 1 0 1 and something like that, because it's a thermometric, where you require output of this one through encoder to get the digital output, right? So every cycle you can have the required transition, and accordingly you can have the output. So what we are doing is we are switching off other circuits which are available at these zeros and these ones, so that at the transition those comparator, those DACs will be on. Going next. So this again, like this has been tapped out. This is another part of the chip where it has taken almost like 0.5 by 0.5 mm square of area, and next, it has been checked in a laboratory, and all the simulations, all the results have been checked. So these are the post layout simulation, and after that we will have the chip measurement results. Going next. So when it has been measured, it is seen that this work is showing me 119 femtojoule per conversion step. If you remember the previous one, it was 195 femtojoule per conversion step. So now it's improving. Next. So same way, other than that, you might not be aware of this structure, 1.5 bit per cycle. When I was doing my PhD almost like 15-16 years back, and I was showing this to our professor, he was saying, so one of the bit is actually broken or what? But it's depending on the SNR, that how much SNR you are achieving. So SNR equal to 6.02 n plus 1.76. So from there you can find out the effective number of bits. So if you have 3 comparators or three outputs like the previous one, then you can achieve the number of bits as 2. However, in case of just 2 comparison like the previous one, if 2 comparator and 2 outputs are there, these are again thermometric code, the output of this one effectively going to give you 1.5 bits, because maximum you can achieve the SNR of so much. You can't achieve the full SNR of something like 12 bits or 12 dB. You can achieve only 1.5 bits effectively. Next. So this is how it has been optimized and how it's traveling through different conversion cycles, because this is going to give me the conversion after having the calibration. You will have the output at every clock cycle. Going next. So this has been also patented. Next. This also has been tapped out. Next. These are the results. Going next, maybe the table. So now you can see after this, when we have the power aware mode plus previous one, which was 119 femtojoule per conversion cycles, I am getting with this work one with 105 femtojoule per conversion step when there is no power aware. When there is a power aware, I am achieving 79 femtojoule per conversion step, and the output is available at every clock cycle, right? So we are not only at the calibration time, we are taking some conversion delay. Going next. So concluding the whole thing, what we have designed is ADC architecture, which is combination of flash and SAR. The comparator and other things which has been designed, it's PVT independent. At least you can learn this, that it's a process voltage and temperature independent. It's a voltage scalable, as VDD is mostly whole circuit is digital, means you can change voltage from other voltage levels. It's not only running at the full VDD, it can give the answer with the reduced one. It's consuming low power, it's very high speed, it's 3.22 reduction in terms of switching speed. It has 27% reduction in overall power consumption comparing to the power aware ADC. Multi-featured on-chip reconfiguration has been done. The frequency of synthesizer operation is also included inside the overall chip performance. Going next. And of course you can go beyond that, because 10 gigasamples second might be the 6G, where you require the high performance optical communication, high performance measurement instruments, 6G communication, and MIMO systems, where such a high speed is very important, and where not you are going to implement with flash and SAR. However, you can include the pipeline, delta sigma or SAR ADC together and achieve even much higher speed and much higher energy compared to the single one. The hybrid TDC, like time to digital converter and other digital time converter, can be also evaluated. Next. So this was my previous student's PhD thesis, whose work I actually kept it over here. Next. And this was part of the SMDP C2SD project, and it was by Ministry of Electronics and Information Technology, those who have supported us. And it was also part of the Digital India Corporation, from where I got the Young Faculty Research Fellowship, and of course from Professor Shauri Chatterjee from IIT Delhi, who allowed us to use his VLSI laboratory for testing, because some of the instruments were not available at the time with IIT Mandi, so I used them. Next. So thank you very much. Thank you all.
Thank you, sir, for sharing your expertise and enriching this session. Dear students, you have got very good insight and you have learned digital electronics and basics very clearly with this advanced topics. And now, if you have any doubt, any query, any questions, then you can ask. Please, students.
Okay. On the last Saturday, we had on the same stage, we have a cloud technology workshop is there, and we have find out that whenever we are giving a prompt of something like 5 to 6 times, the entire software has been made. Obviously, the backside, these are the applications we are seeing. Okay, but backside the hardware and the signal processing and everything is working fine, and that we people are not able to understand. So can you elaborate that only the working on a software, that's not the only the growth. The growth is the hardware and all the hardware and the software and the signal processing, that bit processing, storage, everything should be every technology should be grown up. Then and there we can be on a same platform. So how this basically hardware work right now beyond the what is the AI applications we are visualizing as of now working.
So thank you for this question, because this is very important in terms of students' future, because like when we were studying, I told you, like we also studied neural network and other things which were not having the name AI ML. This was possible in this particular era when the hardware is available, right? And if you are only in AI and ML, and if you are not working with the supporting fundamental thing like signal processing, where all image processing, speech processing is happening along with hardware, then your market is almost zero. There is no role for just AI and ML, because that's just a supporting personality, right? So one has to go with the real fundamental things, and one has to clear that. So that is very important. So thank you, sir. Thank you for this question for all students.
I have another question also. Sorry, sir. Okay. I heard about that. You take architecture of a computer. Okay, the desktop computer you take. Okay, fine. There are various basically components. We can say the CPU, the RAM, and then the other components are there. Why the component basically are connected with a buses right now, as of now? Why they are not connected with a wireless technology? Because I came to know that before 5 years, if they are connected with a Wi-Fi technologies or something wireless technologies, then speed can be something like double or triple times. So why even the right now such architecture has been not evolved? What the challenges we are facing in that one? At that time, one of the challenge was something like hardware level hacking. Okay, you can hack at a RAM level or you can hack at a CPU level. That was a challenges we find out. But again, right now, why the such a technology has not came, which can boost up the speed of a entire system as a manifold.
So that system has arrived already. It's not in market in terms of product, but it's known as the photonics on chip, right? So people are working on it, and but the people are very handful people are there around the world. I know only few people, even US, and very few in India. Some people are separately working on only on photonics, but not on photonics on chip, right? That is the reason right now we are not getting it. However, we are going to see these things very soon, maybe in next 5 years, I think. Mac is working on that.
Which company manufacturing these devices?
Apple, that is what I was saying.
Apple
Mac might be the possible thing in next 5 to 6 years. They are working on it.
Good morning, sir.
Good morning, sir.
Wonderful presentation, and technology is like advancing like anything. My concern is I'm looking after entrepreneurship and family business.
Sorry,
My concern is about entrepreneurship and family business. I think the technology how is there and a lot of talks going about, but how is it reaching to a small entrepreneur, MSMEs and family business? Because it looks very complicated to a simple layman person from business viewpoint. So what are you doing? You talk about entrepreneurship also. So what are you doing to reach and disseminate this to industries existing as well as the new entrepreneurs?
So if I'm answering to that, IIT Mandi is having a catalyst, which is incubation center, and we are not only giving money to the new startups, but we are also doing the handholding. We are teaching them. We are allow them to grow. Not only we are giving the space in IIT Mandi, but this is what we are doing, and this is what actually India requires. That there are lots of wild ideas are there, even from first year or second year UG students, but they are not going into the right direction. So of course, many management schools are working on it, right? But as a part of IIT Mandi, as a part of Catalyst, we do not look at their qualification, but we look at their idea. Accordingly, we do the handhold. We teach them how to grow, and different schemes are there which we are targeting, and we told them how to go with it so that you can get the that particular scheme will be awarded to you. So that is what we are doing.
Thank you. No, I appreciate the incubation has a very limited numbers and limited accessibility. But I'm
True.
talking of a larger class of industries, SMEs and family business who are deprived of all this technology.
I might not be the right person to tell you this.
Thank you.
Yeah. Any other question or anything from student side? Okay. By the way, if you want to reach me, it's Hitesh, my name, Hitesh @iitmandi.ac.in. You can write me mail, or you can communicate with me, whatever your queries are. Right? Thank you.
Thank you, sir. Thank you, sir, for enriching this session. Now it's time to hear from Honorable Vice Chancellor Professor Dinesh Avasthi. Let me briefly introduce him to you all. Dr. Dinesh Awasthi, the Vice Chancellor of LG University, Ahmedabad, is an economist by training and a renowned expert in entrepreneurship and strategic management. Formerly a professor at IIM Lucknow, he also served as the director of the Entrepreneurship Development Institute of India, EDI, Ahmedabad, 2003 to 2015. With over 71 research papers, 8 books publications, reviewed 5 books, and 31 research reports on SMEs and technology entrepreneurship. He has been a member and chair of various committees for the Government of India, Government of Gujarat, non-profits. As a consultant for UN agencies and organizations, he has engaged globally in impactful professional assignments. With immense respect, I invite Sir to kindly address the gathering.
Am I audible? Okay. Professor Hitesh Shimali, keynote speaker of the conference. My colleague, Professor Alok Manke, Director, School of Computer Applications. Distinguished guests, speakers, chair, participating research scholars, my colleagues, students, ladies and gentlemen. We had an excellent presentation by Professor Hitesh Shimali. As a president, I am expected to give some comments, but I'm sorry, I have absolutely no idea, no competence to comment whatever he talked about chip. That the closest I can go to you is chips, which I will keep on eating, otherwise it will be inappropriate for me to make any comment, but I'm sure it must be very, very exciting kind of field, and the country is looking forward to this kind of interventions. We have our Honorable Prime Minister has just inaugurated a big chip company, Micron or something, I believe. So I am sure whatever you talked is very, very relevant and quite enlightening. Some things I could grasp maybe very, very distantly, but I'm not in a position to make any comment. The other thing is about today's conference. Again, I have no confidence whatsoever to talk on this conference being a social scientist. Nevertheless, there are some concerns. Besides those limitations, I'm grateful to the organizers. They took this risk of inviting me to speak, which they should not have, because illiteracy could be dangerous. Well, today we are not merely inaugurating an academic gathering, we are opening a dialogue about the future we are collectively building. For decades, we have argued for optimization, because I found two words, optimization and resilient systems. So from that point of view, I gave a thought that for decades we have argued for optimization. We sought the shortest path, the lowest latency, and the highest throughput. While these merit and these metrics remain vital, these are no longer sufficient to my view. In a world defined by volatility and interconnectedness, a system that is perfectly optimized for a static environment is a system primed for catastrophe. A perfectly efficient power grid, for example, may be brittle in the face of climate-induced surge. A high-performing logistic network can collapse under the weight of single unexpected supply chain disruptions. True modern optimization requires a paradigm shift. We must move from brittle efficiency to adaptive resilience. The events of recent years have reminded us of one undeniable truth. Resilience is not an option. It is essential. It is the ability of a system to maintain its core functionality under stress, to degrade gracefully. It must degrade gracefully and to emerge stronger from the challenges it faces. It means designing systems that anticipate failure rather than react to it. We must build systems that feel their environment, anticipate disruptions, and self-heal in real time. Resilience means preparedness. Climate change, cyber threats, pandemics, geopolitical instability, these are not isolated disruptions. They are systemic changes. To respond to them, a resilient smart grid must, for example, withstand extreme weather. A resilient communication network must survive cyber attacks. A resilient financial system must absorb market shocks. A resilient healthcare system must manage sudden surge. This is this I think was the basic realization, and the realization was efficiency without resilience is a trap, and resilience without optimization is a base. For us, modern optimization and technological advancement for resilient smart systems is not merely a theme now, it is a mission. Optimization techniques such as robust optimization, stochastic modeling, multi-objective decision making, and adaptive control systems are central to the achieving this resilience. We live in an era defined by smart systems. We have smart grids, smart cities, smart supply chains, but smart is no longer enough. A system that is merely intelligent but fragile is a liability. In recent years, we have seen how global shocks, be they biological, economic, environmental, anything, can in fact dismantle optimized systems that lack the DNA of resilience. Our goal over the next few days is to bridge this gap. Albert Einstein once said, the measure of intelligence is the ability to change. I would like to add to it, the measure of a systemic brilliance is its ability to recover. We are the architects of the infrastructure that will define the next century. As we discuss advancements in AI, machine learning, and hardware architecture, which is being discussed, I ask you to keep one question at the forefront of your mind. Does this advancement strengthen the system, or does it merely accelerate its speed towards a potential failure point? This conference is the space for radical collaboration. I encourage all of you to break out of your specialization. The solutions to multi-dimensional problems of our age do not exist in silos. You work in silos and you reach nowhere. So now this is the time when we talk of multidisciplinarity. And talk to people who are from entirely different disciplines than what is yours. So unless you go out of your silos, I think it will be very, very difficult to find out solutions to the problems which are going to face in the near future. Let us remember that our goal is not to create systems that never fail. This is not possible that systems will never fail. Our goal is to create systems that are worthy of trust society places in them, systems that recover, adapt, and preserve. The challenges are significant, but looking around this room, I'm filled with immense optimism. The brilliance gathered here is the most powerful resource we have for this change. We are not just here to share papers. We are here to spark a paradigm shift. Let us ensure that the smart systems we build today are robust enough to protect our tomorrow. Before I conclude, I want to challenge you. Do not spend this conference staying within the comfort of your specific niche. To the young researchers present here, your curiosity of today shapes tomorrow's infrastructure. Ask bold questions, challenge conventional models, experiment with interdisciplinary approach, and most importantly, think beyond publications, think about impact. However, as we pursue resilient optimism, from an economist point of view, I am an economist, we must also ask three normative questions. And in Gujarat, that becomes more important, where Maro Shu and Mare Shu is quite live. So we must ask these questions. Optimization for whom we are doing it? At what cost? And optimized for how long? Given the speed of change, I think we will have to answer these questions, and keeping these questions in mind, we must dedicate ourselves to a mission to build systems that are intelligent yet stable, efficient yet sustainable, advanced yet inclusive, optimized yet humane. The future will belong to those who can design systems that do not just function but endure. As a social scientist, I am of the view that technology must align with sustainable development goals and human values. With that spirit, I declare this conference open and wish all of you highly productive, insightful, and inspirational development. Thank you very much.
Thank you, sir, for visionary words and encouraging students. Thank you so much, sir. Now I request Dr. Alok Manke for the vote of thanks.
So thank you very much. I am presenting the vote of thanks for this inaugural ceremony. I really thankful Dr. Srimali sir, VC Dr. Dinesh Avasthi sir, and all the panelists, all the directors, all the dignitaries, all the session chairs, my faculty member, organizing committee to represent this such kind of conference. So I am very grateful to effort of all the LGICA faculty members, especially those who are organizing. My special thanks to Bhavin sir, who really publicized this conference in all over the Gujarat. Dr. Jignesh Doshi put lot of effort in poster presentation. Professor Manish Garwar for panel discussion. So after that we are continuing with panel discussion, and after that session will be start. So I am really thankful to all of you. Thank you very much, sir.
Thank you so much, sir. At this juncture, we are pleased to announce that the selected papers presented at ICMOTA RSS 2026 will be considered for publication in the Web of Science Index Journal of Information and Optimization Sciences JIOS, as well as in the Web of Science and Scopus Index Journal of Discrete Mathematical Sciences and Cryptography JDMSC, subject to the respective peer review processes. Now, in the recognition of the invaluable contribution and inspiring presence of our distinguished speaker, we now proceed with the memento presentation. I request Professor Dinesh Avasthi to felicitate our keynote speaker, Dr. Hitesh Sriman, with a memento. We now proceed to the panel discussion on designing smart systems and smart carriers, industry insights on AI, optimization, and resilience. May I request our distinguished panelists to grace the stage as their names are announced. We are honored to have Professor Manish Gaharwar, Director, LJ Industry Interaction and Placement Cell, LJ IIPC, LJKU, serving as the moderator for today's panel discussion, which is our next event. May I request Dr. R. to please join us on the stage for felicitation. Panelists, please come onto the stage. I request Dr. Manke to felicitate Mr. Suprit Tare, founder and CEO of Taretas, with a Tulsi sapling. I request Professor Gaharwar to please join us on the stage. I request Sir to felicitate Mr. Dhrumesh Gandhi, Technical Consultant at Synoptech India Private Limited, with a Tulsi sapling. I request Dr. Manke to felicitate Mr. Divyang Ved, Head of IT and Micron Technology, with a Tulsi sapling. Thank you, sir. I now hand over the proceedings to Professor Manish Gaharwar, the moderator, to lead the session.
Thank you. Good morning, ladies and gentlemen, students, faculty members, our esteemed guests. Before we start with the panel discussions, I take the privilege to introduce all our panelists first. Our first panel member is Suprit Tare. I am pleased to introduce Suprit Tare, founder and CEO of Taita, a leading voice AI solutions agency based in Jabalpur. A specialist in conversational AI, Suprit has pioneered enterprise-grade systems like AI Receptionist and lead platforms, making cutting-edge voice technology both accessible and impactful for business worldwide. Welcome, Suprit. Thank you. Our second panel member is Dhrumesh Gandhi. Dhrumesh is a lead technical consultant at Synoptech, who brings nearly a decade of expertise in Microsoft Dynamics 365 and Azure cloud services. A true technologist at heart, Dhrumesh is currently pioneering the integration of AI into enterprise workflows while fostering the next generation of consultants through dedicated mentorship. Welcome, Dhrumesh.
Thank you.
Our next panelist is Divyang Ved, Head of IT at Micron Technology, a leader with over 2 decades of experience managing global IT operations for giants like Ford and HP. Recognized as the future CIO of the year, Divyang combines deep technical mastery in PMP and CISA with a proven track record of scaling complex infrastructure on an international scale. Welcome, Divyang, on the stage.
Thank you.
And now, friends and panelists, I present before a house full of Gen Z, millennials, and even Gen X, right? So this house full of multi-generation people out here. These are the generations which have seen a huge shift and transit in terms of technology. I think if you can relate, these are the people, we are the people who have seen from PCOs to a handheld device, smartphones, which is as good as a computer. This is the generation which talks about the modern features in car. This is the generation which talks about IoT. This is the generation which talks about robots and whatnot. Right. Now, a very no, to break the ice and start with the opening of this discussion. I would like to understand from each one of you one by one what you are champions in your own field. You have done wonderful in your own field. You have been doing excellent. What is that one skill, or maybe more than one skill, that keeps you no, intact in the AI world? That's the first thing that I would like you to share. You can share it in the form of your journey, of your technical journey, which can really impress and make the audience learn about it. Please.
Hello, hi, am I audible? Yeah, okay. So the question is, what is one skill that helps us continue going on in this ever-evolving world of AI? And the brief answer is that you have to learn. There is no substitute of learning. The technological world is changing. It's changing really very fast, and learning to learn is a skill that you all can adopt. The other two things that I would say, apart from learning, that has helped me a lot, and that I believe a lot of students will also help, is that not only you learn, and I guess now is the best time while you are in college to learn something new, but also the second thing is to talk about it. Whatever you are doing, whatever you are building, go to your LinkedIn, talk about it. Open Twitter, talk about it. If you are Instagram guys, go create a reel about whatever you are creating. So that is the second best thing that you can do for you today. So you basically learn something new and then you talk about it. And the third thing that helps you a lot, that has helped me a lot for last 20 years, is to ship it. So basically, what happens is we all start a lot of different projects. Can I get a raise of hands? How many people, how many students create some sub project, side hustle, something like that? How many of you do that? Great. I see some raised hands, right? How many of you actually ship something out? You start and you finish and you ship it. You don't, right? So that is the third thing that I am saying that you need to adopt and to learn, is to basically create something, complete it and ship it. It doesn't have to be big. It doesn't have to be fancy. It doesn't have to be modern. It has to be as simple as a small chatbot, something, a WhatsApp thing that you can do for your parents, a medicine reminder application for your grandparents at home, whatever it is. Create something, build it, talk about it and ship it. These are the three things that has helped me a lot, keeping pace with the technological change, and I believe that is something that can help you as well.
Wonderful. So what he's trying to say is, have a wardrobe at home, but for clothes, not for your IT stuff, right? Use it. Yeah, please.
Yeah. Yeah, you guys can hear me, right? So I would like to continue on. He said that you should keep learning, because once you go out in industry, it's not like that the learning stops. You need to always learn. You need to be aware about what's happening around you, as well as what's coming next. You need to be on lookout for what some major company in your branch or your industry is going to do about, and then try to learn it, not waiting for them to teach you. Even though in industry or college, go outside, learn yourself. What helped me is having a home lab. I try to do things at my own. I try to learn things on my own. You have a lot of resources. You have YouTube. You have now in YouTube as well on shorts for this Gen Z people. I would say the shorts are a small videos that will guide you on a topic to get you started. Then you can use that, learn deeper. Another thing that helped me is to know what to ask. Always ask question, you would get better answers. Even though you feel the questions are dumb, go ahead and ask it. Worst case, nothing happens. Best case, you learn something new. So that's what helped me a lot. That would be helping you guys a lot as well. So yeah, I guess I would say this, that go ahead, try to learn on your own.
Very nice answer. I would say that what helped me a lot is about adaptability. Okay. Technology is changing very, very fast. What my colleagues, panelists have said is 100% correct and 100% true. You need to learn by yourself. You need to be keen learning new technologies, and that's what I did it in my past 20 years plus time. Because whatever I learned during that time in my college probably is not being used now. Even the coding is readily available. You can find the coding through certain LLM model. You can just use it when the coding is ready. So it helped me is the adaptability. So whatever is coming on our way, be curious about it, learn it, use it, and then try to experiment more and more. So that way you will be more relevant to the market which is needing your skills. Not just the degree. Degree may help you to reach to the certain level up to the company, or maybe probably to getting into the certain level of the doors of the companies. If you are trying for a job, or maybe if you are trying to approach certain customers, it will help you to reach, because it helps you to achieve certain credentials. But when you have really learned it, adapted it, grabbed that knowledge, used it, then it will be really helpful. You are ready for the future. So adaptability, I believe, that's more important skill set that you need to continue in your life.
That's wonderful. So you mean to say they need to adapt to basics. I am sure all of the faculty members out here, we focus on the same thing, making students adapt to basics, because in the ever-changing world, you see a lot of technology coming up. Students are really confused. So I have one question popping up in between these discussions, that most of the time we have seen students handling, finding themselves in between uncertain areas, gray areas. So is there any way out really? Do you really think that is there any way out to design uncertainty, or to design how to handle failures? Because see, if I am a student, I may be learning something. I have 10 things to learn, but I'm not sure which thing is going to end up where, which technology, what to do, what not to do, right? So students are generally confused with these uncertain areas. So do you think that this can be really designed?
So I would say the uncertainty is definitely there, and in fact, it's actually a very good time. This uncertainty is beneficial for the students, honestly speaking, at this time. Why? Because if you talk about web application development, for example, or mobile application development, or enterprise application development, for example, whatever large software development, if you talk about that, if you have not yet started doing that, you are 15 years behind people who are already doing it for last 15-20 years now, right? But if you talk about the ever-changing field of AI that is happening right now, let's talk about, for example, real-world AI systems, agentic AI, voice AI that I do. This is maybe about 2.5, 3 years old technology. That's it. So anybody who is an engineer at Google or Microsoft with 15-20 years of experience, he is also at the bottom of the ladder learning the same things that I am learning today and that you can learn today as well. And this will also change. After 6 months, after 1 year, this uncertainty is definitely there. This will also change. But here is the advantage, that because everybody, this tech is so new, that all of us are at the bottom of the ladder. We all can start learning this. And what happens is that when we start learning these new pieces of technologies that are coming up, our brain opens up towards how to basically get grasp of what is happening. And even after 6 months, when the tech changes, you are able to adopt to it. So this uncertainty right now that is happening is actually beneficial for the students, I would say. It is a golden time for all of us to create something. अभी कोड करने की आपको जरूरत उतनी नहीं है कि एक प्रोग्रामिंग लैंग्वेज सीखने की जितनी पहले थी. आई एम नॉट सेइंग कि यू डोंट हैव टू. द फाउंडेशन इज स्टिल वेरी मच important. But now you can create applications, you can sell it out in the market, you can make money out of it, and if you continue to do that, that will help you have a portfolio even before you finish your curriculum, even before you finish your graduation or post graduation that you are doing here. So by the time you are kind of done with your academics, you are job ready. You don't do it now, and then you go out, and then people would still expect, the job interviewers will still expect you to come up with certain skill set to be prepared, which you hadn't done while you are here. So I would say this uncertainty is definitely there. Everybody is uncertain on in terms of what is changing, how the world is changing, but the only answer to that is to kind of kood jao, seekho, adopt, learn and relearn. That's the only way out of it.
Yeah, so uncertainty is definitely there. So what you could do, or what I would do, or what I am doing right now, because uncertainty doesn't end when you are in industry. You would still have that uncertainty what AI is going to do about your job. Basically, you will feel that you would be jobless. But that won't be a case if you are learning on the go as well. You are learning what AI is supposed to do, what you are learning how to use AI. So, or you are already trying to do it. You are not waiting for something to happen, something to be concrete, that now it is the way to go. You need to try it out, and as you said, that jump in, do something. So try it out. You can learn as much as you want and as much as you can. So don't wait or think that that is uncertain. What should I do? What should I don't do? Just do it. You learn something, you try something, you fail, you learn something new. So basically, don't wait to decide, just do something.
I believe the uncertainty is good in certain way, but the AI has not given the uncertainty only to the students. It has created anxiety, as well as some kind of excitement also among all the experienced people as well. And everybody would agree to it. I mean, the professional, the experience, or the students, it has created that. But what I believe that I completely agree with two gentlemen here. The uncertainty is good. The good thing is that we all are in the same boat probably. I mean, couple of steps ahead or couple of steps behind, but nearly all the generations are in the same boat, because this is just recently started, couple of years back, I would say. I mean, in terms of the real use case scenarios. So that means I believe uncertainty is good, but if you learn, fail fast. I'm not saying fail fast in terms of in your academic grades, but you learn it, you taste it, you use it, and if you find it's not working out, improve it over a period of time, then you will overcome this anxiety. I mean, in a long term, and you're market ready. That's what I believe.
So this reminds me of a very what Supreet was trying to talk. A very interesting fact of mine. When I was a student of MCA, we generally have a final semester project to be done. So I took a project with PRL, that's with Physical Research Laboratory, that's with Department of Space. So I went there and I was interacting with scientists, working for some softwares. And I found that they were all excellent technically. So I was trying to find out their degrees. Is there any computer engineer there? Is there any MCA guy there? And I found out no, there was no computer engineer, there was no MCA guy. All were having their basic pure sciences degree, and they were learning things on their own. Right. So that's what you said. That somebody who is X now will be definitely facing something which is not X. Right. True. Now we had done a survey with faculty members and wanted them to put forward their questions. So since from academics we have a couple of questions related to these things. Right. I would like you to please handle these faculty questions first, because this is straight from the horse's mouth. Okay, so what should students actually learn? We are all in a teaching learning process for sure, right? We do our daily activities regularly, sincerely. But still we have this question daily: what should students actually learn?
I would say learn to think, learn to logic, not a technology, not a specific thing. Just learn how to think about it, how to design something mentally, not physically first.
Okay. Anyone else? Yeah.
I would like to add that spend some more time on the fundamentals because the tools are ready. Don't learn just the tools now because tools are ready and there's so many new tools are coming into the market in daily. So like the voice AI, our friend has developed. So that kind of tools, I mean, there's so many new innovations are coming in a day-to-day life. So what students is really needs to learn about is not the tools. Learn about the thinking process, how you can really narrate the business case into the and how you solve these kind of problems. I mean, what kind of the business problems that you can solve, and that kind of thinking process you need to start developing. And of course, your fundamental has to be thorough. While we are working so much in AI, there's also we have really observed that the students or the certain professionals are missing the key insights, which is like the database architectures, or the networking, or the security and all that stuff. So while you're learning the models or the new tools, also think about this, that how you can integrate all this. Then actually there's a combo which is good. So you need to be start developing your knowledge in all these basics as well.
Yeah, I would agree with that. And there is a slight different take that I want to take here is that while foundations are definitely important, most of you are MCA students, you are already learning about data structures, you are already learning about networking, the communication and everything. I would say brush it up and use the LLM. How many of you, perhaps most of you, would have already started using ChatGPT, right? But do you know that apart from ChatGPT, there are so many other tools which are available for your disposal today, and most of these they have a free plan for the students. You don't even need to pay the $20, $25 or $100 or $200 a month. These are free for students, all of you today. So one thing that you can do is, for example, let's say you are learning data structures and you have questions. You go back to your favorite chatting tool. It could be ChatGPT, it could be Claude, it could be Perplexity, whatever you are using. Ask it the questions. Give it some details that this is what I understand about data structure, but these are my questions which are not answered or I am still confused about. Learn using those tools to learn how your basic concepts. That is one. And second, that you can, after once you have done this, the second thing that you can do is to learn to code with these AI tools as well, is because AI is not going to replace coders, but it's a very famous saying nowadays, and I totally agree with it, is that people who learn how to code with the help of AI will definitely replace people or coders who are not using AI to code at all. So you have to definitely start engaging with these tools, because the more you engage, the more time you spend with these tools, you will learn the nitty-gritties about what is the best practices, how you can use these tools to create something today. And then when the tools are changing and evolving, you can evolve with it. The gap would not be massive. There are only two options. Today, you can start exploring these tools and start growing with it and start learning with it. Or you can wait 3 more years, and then the tools would have evolved so much more, then the gap of your learning to these tools or for these tools would be enormous, right? So my suggestion would be to go back to these tools, start using them to brush up your foundations and start creating something new, and start kind of evolving yourself as these tools are evolving as well. So learn the foundation, but also please learn all these AI tools specifically related to coding, specifically related to your job skill or whatever you are interested in, and evolve with it. That is what I would say is a paramount skill that you need to go ahead and start doing today.
Wonderful, thank you. So this reminds me of one interaction, because we, in the pursuit of what next, what better, what do we do for our students, no, we keep on interacting with industries, people like you. So one gentleman, he suggested me that treat AI as your IP. You create your own IP with AI. No, you use AI, you use these tools, and question that we had from our faculty is coding versus systems thinking. I think it's already said with these answers. No. Okay. Next is AI hype versus reality. So is AI hype, whatever we are going through, whatever is buzzing around, no? So AI will cut down these many jobs and a lot of things, right? So is it really a hype, or what is the reality?
I don't think it's AI is a hype. It's reality now. Everybody is using it. I mean, day in day out life. Whether the person is directly using, a person is indirectly using. Rather, you go to the order of food on the Zomato. Also, they may be using in a backend. You may not know, but yeah, it's being used. So it's not a hype. So it's a reality. But what the sir rightly says that the AI is not gonna replace the. Job, or they are not gonna cut here to. This technology is not here to cut the jobs, but of course it will impact in a way that the person will be replaced who doesn't know it, or who doesn't know efficiently utilizing the AI tools in their day-to-day lives. So that's gonna definitely impact their upcoming lives. But AI is not, no, I don't think it's a hype, it's the reality, and we need to accept it, adapt it, and move ahead with it.
Definitely. So AI is a reality, and it would consume you if you are waiting as the second option suggested by you. So you in the industry, I come from ERP industry. So in ERP, 80% is knowledge and 20% is actual implementation or something. So basically, it won't be replaced by AI. It can help you be more efficient at it, but it won't replace you. It can replace you, as he suggested that. It can replace you if you are not using it properly. You don't know how to efficiently work with it to get the results you need. It can save a lot of time if you use it perfectly. I would give you a small example. In our systems, we are reducing around 30 to 40% of work just by using AI, which was, so in terms of hours, it would reduce 20 hours in 100 hours or something project. So that's very helpful, and it helps you design more efficient system because it's normally knows more than what you do. It has access to all of data. So yeah, it's a reality, but it won't replace any jobs, I would say. Not completely, at least.
I have a slightly different take on that. I think AI is both overhyped and underhyped simultaneously. Overhyped in a way wherein if I speak to a customer who is coming from non-technical background, they expect AI to be like a magic box. They want AI now to do everything, even the chores of their home sometimes. And perhaps the robots that people are building will end up doing that, right? So in certain aspects, it is overhyped. But in certain other aspects, which he was talking about, is definitely underhyped. People are thinking that AI is not going to eat my job. It definitely will. If you keep thinking that, it definitely will. See, when ATMs came, they did not replace bank employees. Bank employees actually grew. Now there are, in 2026, according to the statistics, we have perhaps the largest number of bank employees. Those were there compared to 20 years ago or 15 years ago when the ATMs were not there. So when ATM as a tech came, it did not replace people. The job of people got replaced. People who were earlier counting money are not counting money anymore. They are helping with your banking. They are helping with you with your maybe wealth management, right? So the job has changed. So the technology always shrinks certain jobs, but it also always opens new doors and opportunities. It does not eat the jobs, it changes the jobs a lot. There is another beautiful example when calculators were invented and calculators were openly, people started using it. I don't remember exactly where, but a lot of maths professors were not happy about it. They said that, calculators is not something that students specifically should use. It's a technology that will kill the brain, or it will make the the students dumber. We should not use it. But what happened? Did we not started using calculators? No, we actually moved on from calculators to computers and today's world to the AI, right? So the technical shift is going to happen. It is happening. What I would say is that you definitely need to get along with it, start learning it, because the jobs will change. They will not go away. They will change with the help of AI. Every time a new technology is introduced, it has shrunk some of the jobs, but it has also created new opportunities. I suggest that you be on the second group and learn and be on the second group rather than be on the first one whose job is getting shrunk, right? So that is where I believe it's both overhyped and underhyped. Underhyped for most of people. A lot of people think that AI is not going to impact me. I was one of those people 3 years ago. I used to think that the level of coding we do, the 20 plus years of experience that I have writing code for my customers, AI cannot learn that. Now, I see AI writing code in front of me a lot better than I would have ever written it. Ever. And I am seeing it is happening right now. So I am now 100% convinced that my job as a coder is dead today. It's not going to happen in 6 months. It's dead today. What is not going to end is me as a solution provider identifying problems and using AI to create something and help businesses solve that problem is something that has been going on and that will continue to go on. It's just that the process has shrunk. Earlier, what I was doing in 6 months, now I can do it in 4 weeks, 3 weeks, right? Earlier, I needed 65 people team member. Now I can do it with 3 people. So the jobs have shrunk. They are not going away. So in that sense, it is a little underhyped. People have to be actually worried about it. It is eating jobs. It is going to shrunk jobs. You will have to get on the boat as soon as possible. Don't wait for it.
Right. Wonderful. Three incidences to quote here. One gentleman from visited us, and we were in the same discussion of AI. What is happening around? How is it going to impact us? How soon? How later? Right. So this gentleman said that he handles a facility of 700 people, and we have a data migration event happening. Now that data migration thing usually takes 3 engineers, and it takes some 3 months of time to do it. So technically, it's 9 man months of time that the entire process takes, right? The cost. Now they experimented it doing with it with AI, and it just took 10 days straight. Imagine 10 days on one hand and 9 man months on the other hand. So that's the power of what we are discussing. Number 2, one of our alumnus, he visited some time back, and we were again discussing the same thing. Kya chal raha hai? Kya kar rahe ho aajkal? Like that. And he said, "Bas AI chal raha hai aajkal to." And he works with cyber security. So he said, he showed me a project. Bola ye maine ek banaya project. He said, I did not write a single line of code, not a single line of code. And what all? I said, how do you prompt them? He said, voice command. So he did not actually write one word. He said, I used voice command to use all this, to do all this, command thing done, and the entire project is done, right? So yes, what you're saying is it's scary. Yes, it's scary, but where do you go then, right? There's no place to go. You not run, right? You need to face it. Wonderful. Now, one query from one of our faculty members was that AI research versus product engineering. How do we balance that? Versus product engineering. Product engineering. So how do we push, should we push students towards learning on and experimenting with AI models, or do we make them think about how do we design a product or product engineering and like that? How do we balance?
So I would say it's the same. See, AI is not magic pill. You can, of course, you can ask it to go ahead, open Claude Code today and ask it to create a calculator, and it will do it. It will do it. Ask it to create a small game like ping pong, and AI will be able to do it. You don't have to give it a second command. This is called single shot or zero shot examples, wherein you just give it one command and AI will be able to do it, right? But does the world live only on software that is as good as a calculator or a ping pong game? No. We need banking software, right? Now, let's talk about banking software for a minute. Let's talk about the ERPs their teams does. These ERPs, banking software, the software that runs our airlines, railway network, IRCTC is a great example. This kind of a software is is enterprise software. It builds on multiple layers. It requires scale. It requires a lot of different vectors to come together, and then that's called a product, right? So the product engineering basics are still there. People will still need to learn it. It's just that each of these phases or the factors of product engineering will perhaps not be done by a human engineer alone. You might want to spin up different agents who will do it for you, and they will work in synchrony to create whatever you want to create, the larger system, the enterprise system. But it's you who has to understand the system thinking has to be there. What module has to go with what module? Why do I want one agent to work only on database, another agent to work only on API, the third agent to only do my UX work or UI work? And then how do I help them collaborate with each other and make sure that my end result is met, right? So I can do that only when my fundamentals are clear. So I would say that product engineering, systems thinking is definitely needed, because when you know that, you'll be able to build far more complex system, far more easier. Yeah, I think it is definitely important. The AI will help you speed it up, but it's not going to go away for sure.
I'll keep it very simple. I think the research will help you to ignite the curiosity among everyone. And we all of are here because we are curious people, correct? And we have come all the way this far because we are curious, we want to solve something. But the product engineering is of course needed, because ultimately customers or the end user is gonna use product. So the whatever that we have learned from the research base, or whatever the curiosity we have built up, we have gathered the knowledge, everything, ultimately it ends up into the certain product. So it has to go hands in hand. It cannot be research versus the product. No, it has to go hand in hand, because ultimately the customers are going to use products only. They are not going to use your research paper. Just research papers are good to just gain insight, what went wrong, what is good for us, what could be the probable solution. But ultimately customers are going to use products. So both is equally important.
And I would say it's like he said, it's not a or versus, it's a sequence. It needs to happen, research needs to happen, then the design need to be happening, and then the implementation. So you need to actually be able to design something to let AI do work about it. So you need to tell AI how to do it, what to do it. It can do anything, it can make it happen, but you need to tell it in a way that you want it to, in a way your product is supposed to behave, along with what kind of frameworks you supposed to use. That AI is very vast, have vast knowledge. So basically it can take reference from multiple systems, create one for you, but it may not the one that you wanted, or not in the way that you wanted it to happen. So yeah, it's not a or versus, it's a sequence that you need both.
I hope this solves the entire versus problem. Okay, I have one more. No, we are moving towards the end of the panel. I have one more question to each of the panelists. If you were a second year BTech or BCA or MCA student today, what would you do differently? Imagine yourself a Gen Z second year student, computer engineering student, let's say.
When I was an engineering student, in my class we had this fellow, his name is Shekhar. Shekhar, in 4 years of engineering, I saw him in my class maybe 10 times, that's it. During the exams, I mean left the exam time because then you have to come. But in usual classroom setting, Shekhar never came to us. But he was the only guy who was building websites back then, right? He created the websites for NTPC and whatnot back then. After 3 years, we started hunting for jobs. When we were in, the graduation was done, we started going for campuses and whatnot, and I ended up having a good job. Shekhar started ending up his first company, creating his first company. By the time I did my first 3 years in my first job, Shekhar sold that first company for 50 crores. Right? So, by the time I started my first company, he started a second company and then sold it to more than $45 million to Amazon, sitting here in Bangalore. So now, that's a wonderful question. Because if I could go back in time, I would do what he did. I would not go to college. Of course, you have to go to college for the basics and whatever is being taught, go for it. But do not bank on the college or institution alone to take you where you want to go. You have to, there is a massive gap between the academia versus what is happening in the industry, and the institute is not only responsible for bridging the gap. The students are far more responsible for bridging that gap. And I have a framework on how you can bridge that gap today. It's not very difficult. Go today, create one simple small thing every single month and create it. Like you are I'm considering you are MCA students, right? So you are all technical students. So create one small code, one small application and put it in a GitHub repo. That's it. 1 month, one application. That's it. In 12 months, you would end up with 12 different repos of something that you have built, one, and second, you would have gathered the skills of how to do it, and you will keep doing better. By the end of your graduation, you will end up with 15, 20, 30 plus repos that you would go and show it to an interviewer. 95% of the students, even after having this advice or getting this advice, don't do it. The 5% who do, now believe me, when you are sitting in front of an interviewer who is interviewing, let's say, top best students from your college and who are all very good with theory, we are all very good with theory, but then you show them that, you know, this is my Git repo, this is my LinkedIn, I have done 30 different projects which are not related to my college submissions. These are something that I have learned on my own and I built on my own. None of the interviewer can ignore that. Never. So if I am a second year student today, I would go back, I would start learning something new and I would start talking about it and I start saving that in my GitHub repo to start creating that portfolio for when I graduate, I have the experience to show. Even though I've graduated, I am not a fresher. At least I have acquired those skills. So being a graduate or coming fresh out of a college does not make you a fresher. You can acquire the skills today. You have the time. Right now is the best time, I believe, because no pressure from family. Right. No, आपको पैसे नहीं कमाना, कोई और responsibilities नहीं है. This is the best time for you to learn something new. Create your portfolio. Once you go out, once you graduate, you have that to show. You will, one, end up in a good job, or if you don't end up in a good job, you have acquired the skills, good enough skills that आप उसके basis पे खुद you will start earning good money on your own. You don't even need a job then. So if I am a second year student, then I would do that today. Great.
I would cannot go as much as he could, but what I would say, when I graduated, I didn't know the word ERP. I would suggest you guys to know what is around you or what I would do if I was there at that stage right now. I would try to learn the ongoing technologies. I would try to research not only what taught in the college or everywhere, but just go ahead, learn what's going on, what's there. Because that first day I joined, they told me that I am part of a ERP department, and I just asked, what is that? If I knew, I would have been better at that from the start. I learned on the job, but that's just everyone can do it. Just that if you already knew, you would be on a one step higher than where I was when I started. So yeah, so know about the surroundings or what's going on in the market.
Yeah, completely agree with these two gentlemen. You need to be ready. If I would be the second year student, I completely agreed. I like the idea also to build something every month new. Understand that learning, of course the fundamentals you learn into the college, but the learning is not only limited to your colleges. Okay, so there are so many other platforms also that where you can go and brush up your skills, learn more, and experiment more. There are online tools available. There is so many other medias also, labs available, free labs also available, which is free for students. So you should start experimenting with that. And what I also completely agree, there are so many problems around us. Pick up certain problems, at least couple of, and then start building solutions around it. So that when I say that you need to be market ready, you don't need to be market ready just with the degree or the skills. Okay, I know the concept. No, you need to showcase that I know the concept, I have actually evaluated, I have implemented it, it's being used. There is no solutions that you are just simply building it but nobody is using. That's not a good solution. You need to start solving the problems for the people around you. Maybe your father, mother may be doing some jobs, or they may be around your families or the friends, whomsoever it is. See nearby, there maybe must be certain problems which you can solve with your technology or with tools that you might have, and solve that and put it into the implementation. That's a best learning experience, that's a best example, or probably you will gain those kind of experience nowhere else. Okay, so that's my suggestion. That would probably I do if I'm the second year student now.
So it won't be justice if I don't speak on this. So if I were a second year student, I would have surely learned more about journalism. That was what I wanted to do, and would have surely clubbed this IT and journalism how best I can do, right? So I would push students to pursue your interest as well. You all have some interest inside you for IT, for X, for Y, for Z. Don't just suppress it. Identify what interests you, and try to see that what all you are trained in, that helps to grow yourself in that particular field. Right. Okay. So gentlemen, we are almost done. So it's an open house now. We are open for questions from faculty members, students, and other guests. If anyone, I think we have done with everything, but still, if you have any queries, please. Yeah. Mike.
Yeah, actually, as a new student who don't know anything about the programming, where to start? So what would be the first step to learn problem solving skill, and which programming language should we prefer to learn first problem solving skill and first programming language?
I would say no programming language. You need to learn to logic and the fundamentals.
So I would agree with him. Basically, but I would take a different approach. I have started learning via these chat GPT or Claude. I don't now. We used to, for developers, there was a platform called Stack Overflow. Have anybody heard of Stack Overflow? Yeah. Stack Overflow was like our Makkah Madina. Whenever I used to get stuck in a coding problem, I would go Stack Overflow, I would search for that problem, and I would find a solution there. Now Stack Overflow is dead. Very recently. They are now doing version 2 of them, right? Now, why? Because people are not going to Stack Overflow. Why? Because people are going to ChatGPT and asking the question. I do the same. So if I want to learn something, let's say there are so many new things that even I don't know. If I want to learn something, I will open a Claude Code window and I'll say, hey, I'm a newbie on this. I know absolutely nothing on this topic. Now give me 80% of the knowledge that I need to know in 20% of the time. Give me the basics, and if I have questions, I will follow up. So start with the basics first. Start with the first principles first. So it will give me some first principles. It will give me some basic ideologies about that certain topic. It could be programming, it could be anything else, and then I will start reading that, and then it will pick my curiosity and interest. So there would be definitely some topics of interest there, and then I will dig deep into it, and I will ask it to give me more details about that, and then perhaps I will ask it, once I'm done, are there good YouTube videos about it? Are there good books about it that I can read to go in depth? So that would be my learning process about absolutely any topic in the world today. That is how I would start. So it could be anything.
So I'll take that if I'm a student now, and thank you. So if I'm a student now, and if I need to start with something very, very basics, first I will start with the conceptual first. Start thinking about the solving the problem, scalability as well, stability as well, all keeping in mind. I will start with the basics first. And there are, there are enormous tools available. So learning is not only limited that you just study through the colleges. So I will probably agree with the gentleman that yeah, there are so many tools available. Start with the basics, start with the certain concepts, and then start gradually taking steps towards achieving certain things which can be helpful in overall problem solving methodology.
Good afternoon. Am I audible? Yeah, I wanted to ask, as people from the industry to you, uh, there has been a lot of awareness right now being created that WHO just announced that the use of data centers, because of the use of data centers, we are in the current situation of a freshwater bankruptcy. We have only 13 years of freshwater left. And as rightly said, as well, people who learn to develop with AI would be the ones pertaining forward. So I would just like to know your viewpoint on that. How is the industry going ahead with that as well? Because right now, per day, data centers do use 5 million gallons of water every single day, and that is based on the current demand today. In the next 2 years, it might be 1.5x to 2x.
So, if I heard you right, what you are saying is that because AI requires mass amount of hardware and data centers, which actually need a lot of water to cool it down to make sure that the data centers are cool. Is this a good thing that we are doing for our earth or our environment? Is that the question?
Whether that we should continue, and what would be like
If I decide that because of that reason I don't want to continue, the world will not stop using AI, or world will not stop producing more data centers, or world will not stop producing enhancing the AI. On the contrary, there are teams actively working to figure out alternative solutions for keeping the data centers cool. And they are not banking only on water. What they are banking on water right now, because the current infrastructure of the data center works that way, where water is the best option for keeping them cool down. But then that's not limited, and with the evolution of the technology, things are changing. People are now actively creating data centers insides of the ocean, so that they are inherently cool because they are inside of the ocean. There is, like, Elon Musk has a company and he has a plan to get the data centers out of the earth in stratosphere as well. Again, unlimited energy, no need for water, it's all very cool up there as well. So things are happening. Again, these are moonshots. It might not happen in next 3 years or 5 years, but 15 years down the line it will definitely happen. But because of that, if I decide not to use AI today, I think I would be left behind. So I would not, I mean, I would appreciate that they find a solution better, so that, or faster, so that I am doing my own bit for saving the environment. But I don't think that would be the only reason because of which I would not start using it or stop using it, because it doesn't matter. People are still continuing, and people are continuing on both fronts, using it as well as trying to solve that problem of enormous water usage and getting towards more economical, more sustainable solutions. So that is happening already, and it will happen. So that should not be a good reason for you not to use AI today. That's what I think.
So I am coming. Okay, can I add more, sir, please? So I'm coming from Micron Semiconductor industry. We develop data center related memory and processor related semiconductor products. There are technologies available which can cool your data centers naturally without water as well. So there is a liquid cooling and a chemical based cooling also that is being used right now. And if you talk about why the data center needs lots of cooling requirement, so other hand, the other technologies or the other companies like the Micron and so many other companies, PCMC and all companies currently working on something called HVM. They are working on a certain technical solutions which LP RAM or something which is using low power, which does not generate the more heat. So this is already being used. It's very much high in demand, and it's like selling like hotcakes across everywhere. So there are technologies being developed, but just because these technologies are coming or it's already available and not widely being used, will you stop using the AI? My answer would be no. You should not doing that. That would be probably the biggest mistakes of humankind. Any humankind that they would be doing it right now, or as a student you should not be doing it. No. AI is an integral part of our life right now. Okay, so we started our conversations with that AI is not gonna replace job, but it will definitely replace the person who doesn't know it. So there are technologies available, there are certain research being going on which can help to solve this environmental kind of problem, and there are new data centers coming up with the green energy as well. Correct. So that will over a period of time solve the environmental problem, but of course you need to continue using AI and continue learning it.
Yes, we have one
Okay.
question from our faculty.
I want to add on this basically question. Can I add it? Okay. It's a really excellent question. What we should do is, basically whenever we are working with AI and on a complex task, so what happens is that when you are giving a one prompt, okay, and again you are modifying your prompt after a one iteration, again you are modifying the same thing again. So instead of that one, you should plan properly. You should make sure that one, instead of writing a 10 prompts 10 times, write it 2 or 3 times. That will save a lot of energy, waters and every resources. Otherwise, we cannot come out from an AI. AI, we should use it, but we have to plan the properly that entire our prompting, how we should give a prompt. Fine. We cannot do any as a computer application user or something like as a developer. We cannot have any basically chances of doing something like cooling or something modifying the technology. But what we can modify is we can modify ourselves. Write a prompt before, think properly before writing a prompt or giving a prompt to the AI, any basically software. That's the first I think I advise to all of you.
Wonderful, wonderful. I think what Pavin sir is talking about is optimization. It's not just faster algorithm, but optimization is performance plus cost plus scalability and reliability. Wonderful. Thank you so much. Any other questions we have, please? We are open for one last question. Anyone? Wonderful. Thank you so much. Now, there's a surprise. There's a surprise, gentlemen. Ladies and gentlemen. Now, my role is here like a jack. You know jack? I ball and bat at the same time. I ball for you, I bat for you, like that, right? So, thanks. This is better. So, now we have one question from the panel to you, to the educators, to the guests, to the faculty members, to students. We don't need any answers for this. We just want you to think about it and go back and try to see how do you implement it. Are you or are we teaching AI correctly? Number one. Are we aiming for or are we equipped to produce more and more shakers? Do we think of producing shakers? This is the question from the panel to you. Thank you. Have a good day.
That was indeed a stimulating and thought-provoking discussion, sir. I extend my heartfelt thanks to all our panelists. As a gesture of our sincere appreciation and thanks, we would like to present mementos to our esteemed panelists. I request Dr. Manke to join the stage for this. I request Professor Gaharwar to kindly present a memento to Mr. Suprit Tare. Thank you, sir. I request Dr. Manke to kindly present a memento to Mr. Dhrumesh Gandhi. Thank you, sir. May I ask Professor Gaharwar, sir, to present a memento to Mr. Divyang Ved? Thank you, sir. Before concluding the event, I request everyone to kindly rise for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you all. Now going for the concluding announcement here. We shall now pause for lunch, which is being served at basement BSc building. The technical paper presentation sessions will continue at 1:30 p.m. at LGMC building. All presenting authors are kindly requested to assemble at their respective venues. After an enriching day of academic exchange and insightful presentations, high tea will be served at 4:30 p.m. Enjoy your lunch. Thank you one and all for your kind support and cooperation.